Alright guys, so sorry I'm out today. Like I said on the board, Evan threw up at daycare, so I went and picked him up and he's now napping. So I'm going to make this video for you guys. Hopefully it helps you understand applications of right triangles. Now what we're going to do today is first we're going to go over angle of elevation and depression, do some application problems using those two. Then we're going to learn about bearings, and we're going to do a couple of examples incorporating bearings. But first, angle of elevation, depression. Now, this you did learn about in in geometry. An angle of elevation is an angle from a line that is always horizontal. Sometimes it's the ground. It's always going to be parallel to the ground. So our angle of elevation starts on the horizontal line and goes up to our line of sight. That's what makes it an angle of elevation. Elevation means up. Whereas an angle of depression is from a horizontal line going down to our line of sight. Going down. To depress means to go down. Now, I do want to point out also that if I have this object up here, and I say that the object has an angle of depression, I would have to create a horizontal line parallel with the ground, and my angle of depression is going down from that horizontal line to that line of sight, and we'll call that angle theta. Now, sometimes they'll give us this angle, and notice how it is not inside of our right triangle. However, because this top horizontal line is parallel with the ground, that means that this angle that we created up here from the angle of depression, this theta, is going to be congruent to this angle, we'll say alpha. The angle alpha inside of our right triangle. And this is because our two horizontal lines are parallel, meaning theta and alpha are alternate interior angles. Therefore, they are congruent. They are the same. So if ever they give us this angle outside of our right triangle, we just have to find the alternate interior angle inside of our right triangle, and that's how we can solve using trig. Alright, so let's try it. On this first one, it says, adorning the top of the Board of Trade building in Chicago is a statue of Circe, the Roman goddess of wheat. From street level, two observations are taken 400 feet from the center of the building. The angle of elevation to the base of the statue is found to be 55.1 degrees, and the angle of elevation to the top of the statue is 56.5 degrees. What is the height of the statue? So what we're truly trying to solve for here is the height of this little tiny statue up here on top of the building. We'll call this height x. Now, obviously, this side, this x, is part of a triangle with the two dotted lines being the other two sides of the triangle. However, that triangle there, that slim little triangle, is not a right triangle. So we can't use trig here to solve for theta. To solve for x. Instead, what we have to do is we have to create a right triangle. So I'm going to take this statue and I'm going to draw a line straight down from the statue to the ground. Because it is a line straight down from our statue, to the ground, this means that this line is perpendicular, which why can I not draw a straight line? Psh, it's okay. Wow. We're going to draw a straight line down, meaning it's perpendicular, meaning it creates a 90-degree angle. Down here. So we now have a right triangle. What we're going to have to do is we're going to have to first solve for the length on the smaller right triangle. We'll call that y, the length of that opposite side of the smaller right triangle, and then find the height of the larger right triangle. We'll call that height z. And then we'll take z and subtract y to get the height of the statue x. Now first I'm going to solve for y. And y is that smaller triangle, meaning I'm actually utilizing that smaller angle there, 55.1. I'll call that theta. Now, on this right triangle, if theta is 55.1, our opposite side is that y value, and our adjacent side is 400. Based on SOHCAHTOA, the only function here that uses O and A is TOA, T standing for tangent. So I'm going to use tangent of theta is O over A. Our theta here for the smaller right triangle is 55.1. O is y and A is 400. And I multiply both sides by 400 to get it away from the y. I'm trying to solve for y. And we have y is equal to 400 tangent 55.1. And I pull out my calculator, making sure it's in degree mode, which mine is. By hitting mode, you can check. 400 tangent 55.1. And we have 573.39. Then I do the same thing for z. Z is also the opposite side. But this time, I'm not using that smaller angle, I'm using the larger angle, 56.5, because that is the angle on that bigger right triangle. We'll call that alpha. Because I'm still dealing with the opposite side z and the adjacent side 400, I am again using tangent. This time of alpha equals O over A. Our opposite side there is z. Our adjacent is 400, and our alpha is 56.5. And again, multiply both sides by 400. And because I'm lazy, I'm just going to go into my calculator to use my up arrow key to highlight over my previous function. Hit enter. And we have a 56.5 instead of a 55.1. That's the only thing that's changed. And the z height is 604.33. Now I am not going to type in my calculator 604.33 minus 573.39 when I'm subtracting z from y, or z minus y. Because this means if I just type those in and subtracted, it would mean that I'm actually rounding in the middle of my problem, which is not good. You should only be rounding at the very end. So instead, I'm going to use my calculator and I'm going to hit the up arrow key until I have the z height, and you hit enter to bring it down. Minus, you hit the up arrow key again until you're highlighted over the y height, press enter to bring it down, and you press enter again. And we get the most accurate answer possible, 30.948 feet tall. That's the height of the statue. And I just wanted to show you, if I had typed in 604.33 minus 573.39, I would have been incorrect. MathXL would have marked this wrong. Because that 4 there should have been, if I was rounding to the hundredths place, that 4 should have been a 5. So I would have been incorrect. Alright, so now we'll do one more elevation problem, angle of elevation problem, and then we'll go on and learn about bearings. I'll probably do a separate recording for that. Alright, a pilot flying at an altitude of 2.7 kilometers sights two control towers directly in front of her. The angle of depression to the base of one tower is 37 degrees, and the angle of depression to the base of the other tower is 58 degrees. What is the distance between the towers? Round to the nearest tenth of a kilometer. So what I did with the other classes was I helped them set them up, and then I had them solve this. I think I'll have you guys do the same thing. So here, whenever we don't have a picture drawn in trigonometry or in all of Precal, our first step should be to draw the picture. Now, it doesn't have to be super accurate, but I always like to draw little figurines to help me denote the position of things. So it says that a pilot is flying at an altitude of 2.7 kilometers. So I'm going to draw a little plane. I can never seem to draw planes correctly, but it's kind of like a little plane. And this plane has a height, which is a line perpendicular to the ground, an altitude of 2.7. And I'm going to draw a ground line. Now this is perpendicular here. Oof. And there are two towers. Now this should say, I hate how this is worded, but two control towers directly in front of her on the ground. Obviously. But it's worded a little weird. So on the ground, she sights one tower and two towers. And the problem wants to know the distance between the two towers. Oops. We'll call this X. And it also says that there are two angles of depression from the pilot to the bases of our towers. Meaning I need lines to the bases of my towers. An angle of depressions are from a line that is horizontal with the ground to our line of sight. So I need to draw in a fake little horizontal line. The first angle of depression is 37 degrees. Now, this is a smaller angle, meaning it's going to go on the smaller angle of depression. And 58 would be the larger angle of depression. Neither of these is inside of a right triangle, though, so I can't use trig to solve for any values. What I have to do is I have to recognize that this horizontal line is parallel with the ground, meaning I can find the alternate interior angles and place them inside of our right triangle. So that 37 degrees there, if I see what line it's on this larger green line. I follow that green line down, which, if you remember, is called our transverse in geometry, but you don't need to know that. You follow that line down, and this angle here is alternate interior with that 37, meaning it's also 37. And then that other angle, that bigger angle 58, follow our transverse down, is alternate interior with this angle down here. Now, just like on the previous problem, the x value is not a full side of a right triangle. So what we actually have to do is solve for two triangles here. We have to solve for this smaller triangle's base. We'll call that y. And we also have to solve for the larger triangle's base. We'll call that z. Let me use a different color. Let me use purple, so that I can show you, in case you can't visualize it, the two triangles. We have a larger triangle here. So that's the z base we're trying to find. And then we have a larger triangle here. I'm sorry, a smaller triangle with the base of y. That's, oh gosh, here. So you see the two triangles. I want you to pause this video and find the length of z, find the length of y, subtract them, and get your x value. before you resume this video, please have solved this problem. I'm about to show all the solutions and steps. Make sure you're talking with your group to try to help you solve this if you're confused. And if you get it wrong, for sure be talking with your group to figure out what went wrong. Okay, so this is all the work that you should have had, solving for z, solving for y. And you should have ended up with 1.9 kilometers because it did ask you to round to the nearest tenth. So if you did not get this right, pause this video and figure out what went wrong.